So this is an example of implicit differentiation like we talked about. For that first one, it's x cubed times y, which means we have to use the product rule. If we use the product rule, we have to do the derivative of the first, which is x cubed, times the second, which is y. What's the derivative of the first? 3x squared times the second. So we're just going to multiply that times y, plus the first times the derivative of the second. So the first one is just x cubed times the derivative of y. What's the derivative of y? Y prime. Perfect. This middle term, negative 2x squared, does not have any y's in it. So when we take its derivative, it just gets taken normally. What's the derivative of negative 2x squared? Negative 4x. Perfect. And last but not least, this y to the fourth power is a chain rule again, since it has y's in it. The inside is that y. The outside is u to the fourth power. We're raising something to the fourth power. So the derivative of that would be 4y to the third. That's the derivative of the outside. Times y prime. That's the derivative of the inside. What's the derivative of 8? 0. Perfect. Last but not least, we need to isolate the y prime. So everything that has a y prime in it, leave it where it is. If it does not have a y prime in it, move it over to the other side of the equation. So we have x cubed y prime plus 4y cubed y prime equals negative 3x squared y plus 4x. And then both terms on the left have a y prime. We can factor that out. So we have y prime times x cubed plus 4y cubed equals negative 3x squared y plus 4x. And last but not least, divide both sides by x cubed plus 4y cubed. And which answer choice does that match up with? Yep, matches up with answer choice A. It's just that the top is in the different order, but same answer. All right, raise your hand if you got answer choice A. Perfect. If you didn't. All right, you guys, local linearization. What does the word local mean to you? Close by, sure. Like in a small area, in a small neighborhood, or whatever you want to call it. What about linearization? Any idea what that means?
A line that slopes straight.
Yeah, so linearization means that we are trying to force something to be a straight line. So look at this graph with me. I don't need you guys to write this down. We're just going to talk about it. Do you guys see this blue function on this graph? All right, do you guys see this black dotted function right here? Perfect. Do they look like the same line to you? No. So I'm going to go ahead and open this up in Desmos really quick. I know, right? So here's my question. On Desmos, I hope it's pretty apparent that that black dotted line and the blue function are not, in fact, the same line. But what about if I zoom in? Are they the same line? No, not yet. Are they the same line yet? Nope, I can still see the difference. But if I get close enough, remember this is why we learned limits. If I get close enough to this point, -1, 5, eventually you will not be able to tell the difference anymore between the blue function and the black dotted line. Now, can you guys tell a difference at all? If I made everything black and white, could you tell which one was which? No, they're literally right on top of each other. That's what local linearization means. It means in a local area, in a small region, or in a small neighborhood, if you zoom close enough into the line, it looks like a straight line, even though we know it's not. That's local linearization. So here's what we're going to do. We are going to find the equation of a tangent line. So this black dotted function, for example, is a tangent line. We are going to find the equation of a tangent line, and then we're going to use it to estimate points on a graph. Question number 1. Do you guys see this red line way over here? On the tangent line, this y value is 4.41. On the actual graph, it's 0.661. Those are nowhere near each other. They're super far away, and that's because we're at a point that's pretty far away from -1. So let's move closer. All right, we're closer. The tangent line has an approximation of 4.77. The actual line is at 4.257. Still not that close, and we're still pretty far away from -1. Let's move closer. All right, the tangent line has an approximation of 4.94, and then the actual function is 4.907. So we're pretty close, and notice how close we are to the point -1. The closer you get, the more accurate your tangent line will be to the actual value of the function. So we're going to estimate or approximate the value of the function from the tangent line. Write down this first problem for me. I don't need you to write down all the answer choices, just the words up at the top, and then over here where it says approximate the value of f of negative 1.01. In fact, I'm going to erase these answer choices so you don't use them. So the first part of this problem says, let f be the function defined by that cubic function, which of the following is an equation of the line tangent to the graph at the point where x is equal to negative 1. Now, I took it off. So our new directions are going to be something more along the lines of, what is the equation of the tangent line at x equals negative 1? At the beginning of the year, and in a couple instances since that, we've talked about what we need in order to write the equation of a tangent line. What are the two things we need in order to write the equation of a tangent line? A slope and a point. Perfect. A slope and a point. Do we have either one of those two things? Kind of. We don't have either of them in their entirety. What do we have?
The equation.
We have half of a point in the original equation. Okay, great. So we know that our point, half of it at least, is negative 1. We're still waiting on the other half of it. And we do not yet know the slope of the tangent line at negative 1 either. How are we going to figure out this information? How are we going to figure out the other half of the point at negative 1? Plug it into the original equation. Beautiful. If I plug it in, f of negative 1 is going to be 4 times negative 1 cubed minus 5 times negative 1 plus 3. What are we going to get when we simplify that? Four times negative 1 cubed is negative 4. Negative 4 plus 5 is 1, and then 1 plus 3 is 4. So f of negative 1 is 4. So there's our point. Our point is at negative 1 comma 4. How about the slope? How are we going to find the slope of the tangent line? From the derivative. Let's find the derivative and evaluate at negative 1 to evaluate the slope of the tangent line. So the derivative, f prime, is what, class? 12x squared minus 5. Perfect. If I evaluate the derivative at negative 1, f prime of negative 1, I'm going to get 12 minus 5, which is 7. So my slope is 7, and my point is negative 1 comma 4. Now, if this was a free response question, I would want you to write the equation of the tangent line in point-slope form, and then leave it there. Don't do anything to it after that. So that would be y minus y1, which is 4, equals m, which is 7, times x minus x1. So x minus a negative 1, which turns into x plus 1. That's the first half of my answer. That is the equation of the tangent line. So on the previous slide, when we looked on Desmos at the blue graph and the dotted black function, the blue graph would have been this cubic function, and the dotted black one is this tangent line equation. So if we had graphed both of these two things together, you would have seen that this tangent line is tangent to this equation at the point negative 1 comma 4, and that it has a slope of 7. So what we're going to do is we are going to use this tangent line to approximate the value of negative 1.01 on the actual function, since the actual function almost looks like a straight line if you zoom in pretty close. What do you think we do with this number? What do you think we do with negative 1.01 in order to approximate this? Plug it into what? Yeah, plug it in here to x in this tangent line equation. So let's plug in negative 1.01 here and evaluate to see what we get. Y minus 4 equals 7 times negative 1.01 plus 1. You would be expected to do this without a calculator, by the way. So make sure you know how to add these numbers in your head. What is negative 1.01 plus 1? Negative 0.01. Negative 0.01. What is negative 0.01 times 7? Negative 0.07. Negative 0.01 times 7 is negative 0.07. Last but not least, and be careful with the signs. What happens if I add 4 over to the right-hand side? What is 4 minus 0.07? 3.93. Good. Y equals 3.93. Final answer. Now, that is an approximation. That is not the exact value if I would have plugged negative 1.01 into the original equation. However, if this was a multiple choice question, they would have put the exact value on there as well, and it would be wrong. They just want the approximation using the tangent line, not the exact value. All right, you guys ready to try one on your own? No. I believe in you. You can do it. May I erase this? Yes. All right, go ahead and try this one.
Yes, please.
All right, it wants an equation of the tangent line to the graph of y equals x plus cosine of x at the point 0, 1. What are the two things we need to write the equation of a line? A point and a slope. Do we have a point? What is it? Do we have a slope? Not yet. How do we find the slope of a tangent line? The derivative. What is the derivative of this?
1 minus sine.
Good. 1 minus sine of x. In order to evaluate the slope of the tangent line at the point we want, we should be plugging in 0. So that would be y prime equals 1 minus sine of 0. Class, what's y minus sine of 0? 1. Because sine of 0 is 0. So our slope is 1. Our point is 0, 1. If I write that in point slope form, I get y minus 1 equals 1 times x minus 0. If I simplify that, because the ones that are written in the answer choices are all in slope-intercept form. So if I distribute the 1, I get x. And then if I add the 1 over to the other side, I get plus 1. Answer choice D. Now, from there, it also wants to approximate the value of f of 0.02. So if I plug in 0.02, I can plug it in either to point slope form or slope-intercept form. But since slope-intercept form is actually pretty easy to calculate it in, I'll do it there. 0.02 plus 1 is 1.02. So these are our answers. Perfect. All right, I'm going to give you guys another one to try. Now, I will warn you. It doesn't look like this one, okay? It's not like I'm laying out for you step by step by step and just giving you another copycat. It looks a little different in the way that they're wording it, but the concept is the same. You're still creating an equation of a tangent line, and you're still using it to approximate a value. So if you're confused by the way that it looks, please talk to the people in your groups to see if they are able to help you kind of gather the information that's important from the problem and put it into what you needed to put it into. So, try... Ew. I didn't mean to do that. Try this one. I got a question for you. They said, by the way, this is an AP test question. It came from an AP test. It says, what is the value of the approximation of f of 1.9 using the tangent line to the graph? So first of all, we need the equation of a tangent line. What are the two things we need to write the equation of a tangent line?
A slope and a point.
A slope and a point. Do we have a point?
Yes.
What's the point? 2, 1. The point is 2, 1. I know that that's 2, 1 because of this point right here. When you plug in 2 to the function, you get 1. Do we have a slope?
Yes.
Yeah, we have a slope too. What's the slope? 4. I know that that's my slope because if I plug 2 into the derivative, which is the slope of the tangent line, I get 4. So I can write the equation of the tangent line. Y minus y1 equals m times x minus x1. Now, they don't actually want the tangent line equation. They want the approximation of 1.9 using the tangent line equation. So what am I going to do with 1.9? Plug it in for x. Y minus 1 equals 4 times 1.9 minus 2. What is 1.9 minus 2, class? Negative 0.1. Class, what's negative 0.1 times 4? Negative 0.4. And last but not least, be careful for your signs. What is negative 0.4 plus 1? 0.6. Perfect. Answer choice B. All right, last problem. You ready for the last problem?
Let's do it. I think I'm ready.
You need a calculator.
Not ready.
All right, in your calculator, I want you guys to think about this question and try to use your calculator to help you solve it. Which of the following is an equation of the line tangent to the graph of f of x equals x to the fourth plus 2x squared at the point where f prime is equal to 1? Go. Question. What would you do first in order to figure out where the derivative is equal to 1?
I would plug it in. Graph the derivative.
Graph the derivative. Okay, what's the derivative of this? 4x cubed plus 4x. Okay, look up here at my screen. Here is what I would do. If I want to know where the derivative is equal to 1, I would find the derivative, which is 4x cubed plus 4x. And then I would put a second number in the y2 part. I would put 1 for y2. The reason I would do that is because if I graph it, it looks like this. I have my viewing window set from -2 to +2 for x and y. If I graph it, you can see the cubic function. This is the derivative, 4x cubed minus 4x or plus 4x, whatever it was. And then this is the line y equals 1. If I want to know where they're equal to each other, what point am I looking for? The intersection. So I can go second calc intersect, which is option 5. Second calc intersect. The reason I like this one is because it jumps between the curves for me. So my first curve is that cubic function. My second curve is the horizontal line y equals 1. So yes, yes, or enter, enter. My guess is about 2.3. Oops, not 2.3. 0.2 or 0.3. And then it tells me that my intersection is at 0.236 or 0.237. You guys can put either one, 0.236 or 0.237. So that's the x coordinate. 0.236 or 0.237 is the x coordinate. So again, to write the equation of a tangent line, which is what we're trying to do, I need two things. I need a point and a slope. You guys already told me I had my slope. My slope was 1. I know that the x coordinate of my point is 0.237. How am I going to figure out the y coordinate? Plug the x value into what? The original. Plug the x value into the original equation. The original equation was x to the fourth plus 2x squared. So if I go back to the main screen, and I have x to the power of 4, that would be 0.237 to the power of 4, plus 2x squared, plus 2 times 0.237 squared, and that gives me 0.115. 0.115. So the y coordinate of my point is 0.115. And then last but not least, write the equation of the line and point slope form. Y minus y1 would be y minus 0.115 equals the slope, which is 1, times x minus x1, which is 0.237. If I distribute the 1, I get y minus 0.115 equals x minus 0.237. And then last but not least, add the 0.115 over. What is negative 0.237 plus 0.115? Negative 0.237 plus 0.115. Negative 0.122? Let me see. Yep, answer choice E. X minus 0.122. All right. Your homework tonight is not on this. Your homework tonight is on yesterday's mean value theorem. This will probably only be on the AP test like one time. It's not a very huge topic. Mean value theorem, though, I want you guys to get practice with that so you guys can practice on your own.